The next thing we want to look at is parametric equation. So sometimes we're given equation that they are written in terms of a third variable. Example, x is equal to t squared. So just for clarity, x is equal to t squared, x equal t squared, and y equal to t minus 1. Right? So both x and y are written in terms of t. Now, how are we then going to find dy by dx? That's ultimately what we want. The first derivative to find dy by dx, right? So in order to find dy by dx, we have to just remember chain rule. And chain rule tells us that dy by dx is just dy by something times something by dx. Now, since both of these are written in terms of t, we can say that dy by dt times dt by dx is equal to dy by dx. Now, this is known as parametric differentiation. So we're going to have to differentiate x in terms of t and y in terms of t in order to find dy by dx. So here I've just attached some notes for us to understand clearly what it really is. First, what's a parametric equation, right? And then how we use chain rule to get derivative of parametric equations, right? And then the second derivative now is d2y by dx squared. How do we get d2y by dx squared? The second derivative of a parametric equation is just given by the simple formula. In order to find the second derivative, d2y by dx squared, you just have to use a simple formula that it's equal to d by dt of dy dx, the d by dt of dy by dx divided by dx dt. So it's divided by, whatever this results work out to be, it's divided by dx dt. All right, not going into too much technical proof of it. And this is where it originally starts from though. But we just need to know how to use these two formulas to find dy by dx and d2y by dx squared. These are the most two important things. If you notice, I don't touch the proof of it or explain what parametric equation is. Parametric equation is just simply when we don't see y in terms of x. Now we see x in terms of t, y in terms of t. So a third variable is introduced, and so x and y are defined parametrically. All right. So yeah, so t is known as the parameter that connects the two variables x and y. So let's look at some examples, which is always good. Let's say, for example, in one, we have x is equal to 3 minus sine t, right? X is equal to 3 minus sine t, and y is equal to 3 minus cosine t. And we want to find the two derivatives. So to find dy by dx, with parametric equation, it would be dy by dx is equal to, dy by dx is equal to dy by dt times dt dx. And so dy by dt was, first we need to find dy by dt. Now if y is equal to 3 minus cosine t, then what we can say is our y prime or dy by dt is just, when we differentiate cos, we get minus sine. So what this is really working out to be is sine t, and then when we differentiate, this would be x prime or dx dt. When we differentiate minus sine, we get cos. When we differentiate sine, we get cos, but it's minus sine, so we get minus cos t. Right? And so dy by dx would work out to be dy by dt, which is sine t, times dt dx. Now look at this now. This x prime right here, this is not, what we just found is not dt dx. this that we just found right here, this x prime is just really, so let me write it out here. This x prime that we just find, this is dx dt, but they want dt dx, right? And so what we're really multiplying by is 1 over dx dt. So it's 1 over dx dt. That is dt dx, 1 over dx dt, right? And so what we need to then do then is whatever dx dt is, we're going to say 1 over that thing times sine t. So this works out to be sine t times 1 over dx dt. And dx dt is minus cos t, so it is 1 over minus cos t, right? And so what we're then getting is sine t over minus cos t, and that is sine t over minus cos t, and then sine over cos is equal to tan. And so this works out to be minus tan t. So that's what we're getting. This is just minus tan t. All right? Now that we find dy by dx, so dy by dx is equal to minus tan t. Let's say we wanted to find the second derivative. The second derivative, d2y by dx squared, the second derivative is given by d by dt of dy by dx. The second derivative is given by d by dt of dy dx divided by dx dt. That's equal to d by dt of dy by dx divided by dx dt. And so what that works out to be is d by dt of dy by dx. That works out to just be, let's find the derivative of dy by dt. When we differentiate tan, you get sec squared. So what we're getting is when we differentiate tan t, we're getting sec squared t divided by, now dividing by dx dt is the same as multiplying by dt dx. Multiplying by dt dx, and we found already that dt dx is 1 over dx dt. So it is multiplying by 1 over dx dt, which would just be multiplying by 1 over minus cosine t. Minus cosine t. Now, when you're multiplying sec squared times 1 over cosine t, remember sec squared in general is 1. Sec squared by itself is 1 over cos squared t. And so what we really have is 1 over, remember this is sec squared. Sec squared is really 1 over cos squared t. And so now we have minus 1 over cos squared t, and it's being multiplied by 1 over minus cosine t. So what we're ending up with is cos t, cos squared t times cos t give us cos cube. And then the negatives will cancel. So this minus 1 here will cancel this minus 1 here. And so what we end up getting is that the final answer for the second derivative is 1 over cos cube t. 1 over cos cube t. And some people might go further to write this as, so let me finish it up here, that the second derivative, d2y by dx squared, some people might go further to say that that second derivative is equal to 1 over cos cube t or sec cube t. Sec cube t. So that's what we're getting. That derivative is sec cube t. Easy.